key, but I have a specific reason why I have RSA 2000 bit key. Yes. And it is a kind of tradition. We Japanese or Chinese start our presentation. I apologize for my speech. Usually, you guys in Western countries start their presentation by some jokes. So it's a different culture. And yes, in our culture, the 2K key considers good still. And my concern or my major point is that key size is an important factor too, but it is a single factor among others. And I care how or where to put my private key. And my concern is how I can control my own crypto computations. It matters to me a lot. And however, here we had a dilemma: better control versus users' computing freedom. I mean that smart card is considered better for your security, and it's better control of crypto computation inside a specific special purpose computer, not on your general purpose computer. But card readers tend to be proprietary, and the card itself tends to be proprietary. And the access to the technical documents for crypto engine, crypto accelerator, tend to require non-disclosure agreement between semiconductor chip vendors. So, fortunately, the protocol itself, OpenPGP card protocol itself is publicly available, thanks to a team who wrote the document. And the free implementation of the driver, the host PC part, is in free software. But so basically we had a dilemma. Should we use proprietary card and card readers, or we keep using general purpose computer for our crypto computation? So my original purpose for token is that I wanted to improve this situation. And but these days, you see, in the Debian community, basically the standard is 4000 KB, and now we have another dilemma: longer key lengths versus better controls of private key by free software. So, but my hope is that in sooner or later, say 1 year or half year or 1 year, we won't have those kinds of dilemma anymore. And when we introduce ED to 5519 and CARB to 5519, and it is okay for the Debian community about their strengths, then we will have both better control and computing freedom and conform to Debian standard or Debian culture. That's my hope, perhaps until next DevCon in Germany. And that's basically my excuse. And let me explain in detail. I'm talking about Gnuk, which is the software implementation of OpenPGP card protocol. And the FST01 is the reference hardware, which is PCB design and Creative Commons. Yes, and NeuG is true random number generator implementation. And FSM Go. 55 is happy happy hacking code. Yes. This is another story, but this is.
Hold it higher.
Yeah.
Yes, it is the Debian logo in action. Yes. But this is not totally related to crypto. This is just a happy hacking. And the code is available at my site or Gitorias. And the product requested one is available from Chinese company. It costs something like $35 US. And it only sells 10 pieces per month. Yes.
Can I see the one before?
Yes.
Can I see the one before?
Which one?
That one.
Yes. NIIBE Yutaka or Gitorias.
Do you object to it being streamed?
Okay.
No, it's fine for you.
Okay.
Everything is available there. Hardware design, software, and some manual. So we had a session about the random number generator, and we discussed there. They discussed about the possibility of Kickstarter or something. Yes, yes. In this way? And it's on already? Yes. Does it work? Thank you. And but see, it doesn't sell a lot. So, and actually, I had a campaign from November to this June, and for selling random number generator standalone device, but it says 1.5 piece per month. So I don't think it, but it's just a Japanese market. So I don't know. But Gnuk Token sells better than random number generator. Yes. And here's the history. I got OpenPGP card version 1 in Germany, Karlsruhe. The conference name is Linux Stack. And I found it is very useful, and it is secure, but unfortunately it requires proprietary card readers, or the implementation itself is proprietary. Yes. So I wanted to change the situation, and I tried using 80 mega in 2008, but it takes 5 seconds or more for RSA 10 1K key. Yes, I demonstrated it in India and in Tokyo in 2009. And I changed my controller to superior one, STM32. 80 mega is just a 8-bit computer. And this is the STM32 is an ARM-based 32-bit computer, which runs at 72 megahertz, and it's okay for me. At that time, it requires 2 seconds to sign, and now because I hacked, and now it takes 1.4 seconds to sign for 2K key. Yes, I demonstrated it at Force Asia at Saigon, and then I joined GNU PG development to improve the situation of the PC side, host side. Yes. At that time, GNU PG only support 2K key for card, even though the card itself support 4K key. And in 2011, I discovered a good do-it-yourself way for GNU, specifically abusing existing kit. We have a educational kit. Yes, this one is educational kit for 8-bit computer. This part, we have a 8-bit computer, and this board, the price is less than $10 US. But fortunately, we have a dongle here, and it uses 32-bit computer. Yes, it's a somehow funny relationship. Yes, this is mainboard computer with 8-bit capability, but the dongle uses 32-bit computer. We found this, and we found the way to take advantage of this part. Yes. Yes, so I wrote this document, how to use this 32-bit computer for GNU in 2011, and I promote this new way. This is a kind of hack against semiconductor chip vendor. And if you have some skill, it doesn't require superior skill. If you have some basic skill of electronics, I really recommend this way to produce your own Gnuk token. And basically, it's simple. Here is a USB cable, and cut it off. And then using this board and make it small, and connect the cable. That's all. And actually, here is an implementation. Yeah. So since 2011, I recommend my friend this way of putting their own private key, OpenPGP key. But many other usual, normal people complain it's too hackish or it's against semiconductor vendor, perhaps, somehow. So I designed my own hardware reference implementation in 2000. It was in summer in 2011. Yes, and still, yeah, I claim that here we have a free design. Please use this PCB design to build your own token. But people still complain. You see, that it is impossible for us to manufacture the Gnuk token, even if the hardware design is free hardware design. So I asked manufacturing in the Chinese factory to manufacture, in production, many mass production in 2012. At that time, I expected the people who complain should buy my product, but it turns out the people who complain is basically complaints. Yes. I figure out. Yes. So now we have a free software implementation for token. cryptographic computation, as well as we have a free design for reference implementation. And then, at that time, we had no good true random number generator. So at that time, Gnuk didn't have a feature of key generation by the device itself. We always have to put our key from generated on our PC, and we register. We upload our key into the device. That was a way. Fortunately, RSA doesn't require any entropy for when we sign the key. Yes. But I have to, around 2012, I was trying to implement ECDSA for better security, but ECDSA requires some entropy, even for signing, not only key generation, but only for signing. Thank you. And so I implement NeuG. NeuG is an implementation of a true random number generator. And I had a campaign in Japan for the better entropy. Yes, that's a history. And let me explain the Gnuk more. Sometimes people expect one-time password token when we say token or cryptographic token. But it's not a one-time password token, but a token for OpenPGP. And it is, yes, this is my statement. It's by free software, it's for free software, and it's of free software. Gnuk itself is free software, and we don't require its developers, no proprietary software. We require no proprietary software such that develop for development environment. And in version 1.0, we use Chibi OS RT for thread library, and the Polar SSL for AES and RSA, and we use the SHA-2 implementation by Brian Gladman. And in 1.1, I use my own thread library, and I wrote the implementation of ED to 5519 and curve to 15519. Yes. And let me introduce NeuG. NeuG is the name of a set of routines for true RNG. It is used in Gnuk, and as well as I use NeuG for NeuG standalone device. It's written in C, and it's for STM32F103 only specifically. But perhaps it could run on other STM32 process microcontrollers. And it uses output of AD converter as a source of entropy. If you have some experience using AD converter, the LSB has always unstable. Least significant bit of AD converter output is always unstable. So it is considered, we can take some entropy from AD converter. And we use built-in temperature sensor and built-in voltage reference and unconnected analog inputs as a source of analog inputs. Yes, putting those analog values together into conditioning components of SHA-256 we generate random number sequence. Yes, and here is the reference. Sometimes people don't like this organization, but the document itself is very good. Yes, usually we used to have a good document by German standard, German information technology standard agency or something like that. But speaking about true RNG, the German standard is very difficult to implement into such a small computer. They require higher standards. Basically, they require examining the bit by bit, how to say, the examining and evaluate the random number sequences heavily, and it requires more CPU power. Yes, so generating would be easier than examining the random number sequences. And the German standards is very difficult to implement onto the smaller device. On the other hand, this standard, its status is just a draft, but it doesn't require much testing in runtime testing so it is okay. It is in practice easily implemented onto the smaller device. Yes. And generally, I tested generated sequences on PC using the dieharder or traditional STS test 3, and we have a test user 1 and another one at SourceForge named Plucked-Land. Plucked-Land is not that popular, but this one is a very good test suite. Yes, and NeuG standalone device just use CDC, I mean communication device class. So it's a plain byte stream. Yes. So no special driver is required using NeuG standard device. Yes, and by changing the TTY discipling, we can select raw ADC data, or after CRC 30-second filter or SHA 256 filter, we can select. Yes, and that is no driver required. And just use RNG or RNG tools. Yes, that's basically my explanation. And I want to demonstrate somehow. Yes, I already demonstrated the DIY hack of this board. And I always bring my key. Yes, yeah, this is the one. Yes. I use the cover of eraser, so it's a kind of camouflage. Yes, please.
I was just wondering if you have.
Yes.
Wondering if you have any of these for sale here.
Yes, but I'm afraid that it's against the code of conduct or something. Is it okay to sell here? Yeah. I'm afraid that the university has some code. This conference is not for commercial activities. Is that okay?
It's exactly between you and anyone.
Just between individuals. That's okay. Okay.
So I'm not trying to turn this into a sales talk. I'm just curious to know if you have.
I have. Okay. Some.
How much?
That's 35 US dollar. And actually we have two: the NeuG standard device, NeuG standalone device, and
Gnuk token. Yes, but here we have an issue. I have to explain that GPL version 3 requires when you distribute code, binary code, say, I have to distribute GPL version 3 itself together. So so actually that if you have a computer, you can try this one. I put GPL3 together with NeuG, and when you insert that one, the standard mass storage device pops up, and it includes GPL version 3 to conform GPL version 3. So after that, then, you can use the NeuG standalone device. So it's somehow complicated, and it is introduced after NeuG, and I have to say that Gnuk token doesn't have that feature. So I need to comply GPL version 3, I need to output GPL version 3 in paper, and I have to give you GPL version 3 together with Gnuk token when I sell. That's somehow the practice. Yes. So that's so I have to I should explain another term. It's in a transparent tube, and I sell ST01 in 3-way. One is bare board, and another is the one in the transparent tube, and other one is with enclosure, but it is open. So it's transparent and open. That's my point. Yes. Yes. So, and I should demonstrate online. Yes. Where is my eraser? Yes, my eraser. Yes. I don't say this is my key. This is my eraser. I just put my eraser into this computer. And here is the output of card status. And it's only 2K key. And here is my fingerprint. Yes. This is the card number card number is defined by ISO standard, and this number is for our organization FSIJ. So I ask my number F517. It looks like FSI and J. Yes, similar. And then I'm using this token for SSH access to. So actually, I'm using this portal box, and it takes 1.4 seconds to sign. I input my passphrase, and it takes 1.4 seconds, and I can access the SSH server by SSH. So see, it is acceptable. It's not so. It doesn't take so long time. Yes. So the signing is similar. See. I made this yesterday. Yes, let's try. Yes, sign it again. No. Yes, it takes about 1.4 seconds. Yes, so I think that it is okay to use. Yes, but it is only using RSA 2K key. Yes, and I also demonstrate the NeuG standard device.
So did you try to?
Yes.
Did you try to measure the time for 4K key?
Yes, in the I tried. I measured the 4K key, not for full stack, but just I measured the time for using debugger for the routing only, RSA computation routing only, and it takes more than 5 seconds.
More than 5.
Yes.
So that's maybe too slow.
For me, it's not my option. Perhaps for signing, it would be okay. But for using SSH access, it's not my option. 5 seconds considered too long for me.
Okay.
Yes. So let me show you the NeuG standard device, standalone device. Then, okay.
NIIBE,
Yes?
how many keys can you put on the card?
Three.
Any size?
The question was, how many keys can you put on the card?
It is OpenPGP card compatible. OpenPGP card can handle 3 keys. The primary key, key for decryption, and key for authentication. So we can put 3 private keys onto this card. Yes.
So it seems like that might make it difficult to do key rotation. Mm-hmm. In particular, if you wanted to have a second encryption key that you started to use as you were fading out your old one, you still wanted to be able to decrypt your old messages.
That's a very good question. Yes, we can use. People sometimes use such a practice for keys on PC, but OpenPGP has the scenario of OpenPGP card is limited to just 3 keys.
Okay.
So you can change the encryption key on the 3 key registered on the card can be changed one by one, but only 3 key can be possible to store.
Okay.
Yes.
Is there any thought about changing that to permit?
In theory, it isn't that hard to change the capability. Say supporting more keys is basically not that hard in terms of Gnuk implementation, but we need to change the specification of the OpenPGP card, and we need to somehow standardize the way to handle keys on the OpenPGP card.
Okay, and
Yes.
would the discussion for that take place on GNU-PG Devel?
No,
Where does this standardization discussion happen?
between me and Werner Koff and Akim.
Okay.
These 3 discuss, and now our consensus is that it would be better to use GPG agent protocol itself directly by USB.
Yep.
Currently, we use the hard protocol, yes, but it would be better to just implement GPG agent protocol directly by USB. Yes, that's our consensus now.
I like that. And then that would permit you to put arbitrary numbers of keys on the card.
Yes, yes. It will be transparent. The hardware or the specific hardware or the storage on general purpose PC, it will be transparent.
Okay.
Yes.
Thanks.
Yes.
A question. I wonder if you plan to support 4,000 keys.
Yes.
Because right now, for example, I have a crypto stick from Germany, and it's okay, but right now it's out of stock. I wonder if there are other alternatives to that device.
There are some. These days we have multiple implementation for OpenPGP card.
Yeah.
I mean that the original implementation was done by Akim, by the card, and also the German guy produced crypto stick.
Yeah.
Yes, but unfortunately it's out of stock. But using crypto stick, you can, although the card implementation itself is proprietary, the card reader implementation is free software implementation. Yeah. Yes, and these days, YubiKey, you know the company YubiKey? YubiKey has an implementation of the OpenPGP card protocol. They have a device for such a crypto computation by their product. And there are another implementation by Java. There are some activity around a smart card using Java as a language to implement those features. And it would be possible to use some Java card implementation to use OpenPGP card protocol. Yes. But my recommendation is that Gnuk is stable enough now. And I think, if I remember correctly, last month or 2 months ago, we introduced, someone sent us patch to support another HSM hardware security module for OpenPGP. So perhaps the newest version of GNU PG supports another hardware security module. So we now have multiple selections, and some of them support 4K key, luckily. Yes. And now I open the file manager, and here we have a GPL inside the device, and README, and when I unmount this storage, now the CDC is available. Here, the NeuG True RNG, the manufacturer is Free Software Initiative Japan, and we can access TTY ACM0 for random number stream. And here is a point. Our organization, FSIJ, has a vendor ID. Yes, for USB. Yeah. And because because I have a configuration here for UDEV, the script automatically runs when I insert NeuG standalone device. And here is a script to invoke RNG daemon for this device. now this computer has enough entropy from the device, and the RNG daemon watches its quality. Yes. So it's just a plug-and-play device for better entropy. Yes. But I'm afraid that people usually don't buy such a gadget. Yes. People prefer cryptographic device than entropy device, it seems. Yes. But you guys hackers love entropy device, perhaps. Well, other questions or suggestions or comments? Yes, please.
So what is the maximum key size?
The
question was,
of
what is the
GPG?
maximum key size?
For the Gnuk.
Gnuk is 2K, only support 2K.
Okay.
Yes.
Does the Gnuk contain the random number generator at the same time?
Yes.
So you can buy it separately or with the Gnuk?
It is possible to use random number generator on the Gnuk, but we need some special driver. The protocol is based on the basically the card reader protocol. So the noisy standalone device would be easier because it's just a stream of random byte. Yes. So if you write some driver, then you can take advantage of the Gnuk, and because Gnuk includes a true random number generator, you can use it. Yes.
So I don't know enough about the actual USB protocol. Would it not be possible to present two different endpoint devices from the Gnuk? One of which looks like
It would be possible. It is possible to have two different devices on the same channel. But yeah, in theory it is possible. But the current implementation doesn't do that.
Okay.
Yes. But it requires more. It is possible in theory, but in practice we require. We need to change the implementation, and the implementation will be more complex. And my idea is that basically I want to keep the code as simple as possible. Yes.
That's fair for an important device like a cryptographic token. I can see that.
Yes.
The elliptic curve implementation would require different hardware from the existing Gnuk that does the RSA?
Actually, the Gnuk support multiple hardwares. At the start, I didn't have my own referencing hardware. So I started by the general purpose evaluation board. Then I found some hackish way of using educational board. And then after that, I built my own reference implementation. So it is easy to port Gnuk to other evaluation board or your own board. Yes. Gnuk doesn't require special things. Yes. And the NeuG also requires special hardware. It uses just an AD converter, and our entropy source is not a diode, just an ADC. So it's simple to port. Yes. So I think that it's very much fun to use the code itself. Yes. So I'm running out of time, so please feel free to discuss later in person. Thank you very much. Yes. Yes.